Welcome back to our series of solution and explanation to competitive coding. Today we are going to solve LeetCode question number 83, that is remove duplicates from sorted list. Okay, so let me read the question first. So the question says that given the head of a sorted linked list, delete all the duplicates such that each element appears only once. Return the linked list sorted as well. Okay, so what the question is saying, basically we are given the head of some sorted linked list. Sorted means the elements in the linked list are sorted ascending order or some order, or in any order. We don't care about that. Okay, delete all the duplicates such that each element appear only once. Okay, so we have to, if there are like if the list contains duplicate elements, so we have to remove all the duplicates such that each element should appear only once and not two or three times. Return the linked list sorted as well, and we have to return the head of like linked list, so it should be sorted. Suppose this is our example. In our example one, the list has three like nodes, and two of which holds value as one. So these are like duplicate values or duplicate nodes, so we have to remove one of those nodes, so our list shouldn't contain like duplicate elements. So, and we have to return our like list in the sorted order. In our example 2, like if there are two ones and two threes, so we have to remove one and one three, and we don't have to remove two because it is not duplicate, and we have to finally return our list which contains no duplicate elements, and it is also in sorted order. Okay, so let me read the constraints also. So the number of nodes in the list is in the range 0 to 300. Okay, so they didn't mention in the examples. So our nodes, like number of nodes, could be something between 0 and 300. It could also be 0 and 300. So let me take care of this one too. Like we can check if, like if head equals null, we can return null because there are no elements, or we can return head or null something. To return, I can say head because it is also okay null. Okay, so we have taken care of that. And second constraint is that node dot value will lie with something between like minus 100 to 100, and the list is guaranteed to be sorted ascending order. Okay, so the list, they are guaranteeing that the list is sorting ascending order. So this, what sorting does is that we don't have to keep track of like elements which are already visited, or we don't have to create any hash map or hash set. So what we can do is that compare the neighboring elements to check if they are same. So we don't have to create an extra like data structure to contain the value of visited elements, or the elements which are already appear to remove the elements. So let's see how it could be coded. So suppose this is our linked list initial. Suppose this is our example linked list. So in this linked list, I have actually reversed the ID. So in this linked list, like 2 is duplicated, and if it is actually not duplicated, it is triplicated. So we have to remove two 2's from the list and return the list which contains only non-duplicates element. So initially, our head points to our like first node, and we have to make some temporary list node so that we can traverse the whole list, and our head will retain in the first position. Okay, so what we are going to do is basically we are going to check like the value of current node, what temp is initially pointing, and the value of the node that is our node pointing to, that is next node. If they are same, then what we are going to do is that we are deleting this node and making our like temporary nodes dot next equals to next dot next. That means whatever our temporary node is pointing to, we'll make our next to its next. Like if suppose this is our first node, and this is our second node, and this will be our third node, and this one is fourth, and this is fifth node. So suppose initially our like if the elements, not in this case, like our first and second have different values, so what we can do is, like suppose if they have same value, so if my first is pointing to 2, and if our like value of first and second are same, so what we are going to do is that make our next, that is our reference to second node, will be lost, and what we are going to do is that we'll refer to next dot next. That is, if this is pointing to 2, then we'll make its next to whatever our 2's next is. That is, we'll make our third node as next of our first node. So this reference will automatically be lost, and this node will be deleted, and so our duplicate will be removed. But in this case, as our first and second are not duplicate, so what we are going to do is that if suppose these are not duplicates, so what we can do is that we can simply move our temporary variable for like to the next node, and make our this one make our temporary to point the next node, and so that we can check like for the rest of the list to check if it is. If so, suppose this temporary variable is pointing to second node, and this is my first node, and this is my second node, and this is my again third node, fourth node, and fifth node. Okay, so now like in this case, our temporary variable at our temporary node is pointing to second, and we check whether the value of second node and third node are similar. And we found that yeah, these are similar. So what we do is we simply remove this reference, that is reference of second node pointing to next to its next dot next, that is to third or fourth node, that is next of our next node, that is if it's referring to next is third node, but we will make whatever it is next to our third node, that is will refer to our fourth node. I hope it makes sense. And when we check that, okay, we now have delete this node, and again we have to check if like value of second node and fourth node are not same. We found that these are also same. So what we are going to do, but now its next is pointing to fourth node, so automatically we'll do again next dot next. So our next will be now moved to from fourth. Fourth is pointing to fifth node because next of fourth is fifth. So our next would of two would move to like directly to fifth node, and now we can move that. We can check that our second and third like our value of second node and fifth node are not same. So we can move our temporary variable to the last node, and we check that temporary dot next is null. Now we can return our head to get the solution, or to get final solution, to return the final solution. So let me code this to you so that you can understand in coding sense. Okay, so now we have taken care of like constraint, that is if we have 0 nodes. So now we can move further, and we can create our like some temporary node. So we can do is list node, if list node some temp, I can say okay equals to, initially it is pointing to the same node what head is pointing. Okay, now I can do my while loop. While suppose temp dot next is not equals null, what we can do is okay, we have to check if like temp dot val and temp dot next dot val are same, we have to move our temp dot next to temp dot next dot next. So if like temp dot val is equals to temp dot next dot val, if they are same, what we are going to do is we are going to make our temp dot next is equals to temp dot next dot next. And but if this is not the case, in the else part, what we can do is like the value of two nodes are not same, then we have to move our temp. So our temp would become our temp dot next. Okay, now we can return head to get the solution. Okay, so we can do is return head. Okay, I hope it should work now. Let me check. Yeah, it did work. So let me now finally submit our solution code to check it for its optimality. It did work, and it is I don't think so it is showing 48%. It doesn't matter because we have used only one variable, that is of n time complexity and of one space complexity. So hopefully you enjoy learning, but if you have better approach, you can comment in the comment section below. And thanks for watching.